All right, this is Mr. Weideman, and I am going to do some example problems that are indicative of your homework assignment for section 5.4, graphs of sine and cosine. Now, in class, we did a lot of translations of sine and cosine functions, but in your homework, you have a lot of your problems which are match the graph to the equation. So instead of an equation and then we get our data points and we make a graph, here we're going backwards. So they're saying, okay, some of this, they are just asking you to develop the function from scratch, not even match. Well, what function is this going to be? Well, let's look at its main features. Probably one of the biggest hints that I start with is, does it pass through the origin, yes or no? If it passes through the origin, then you can pretty much bet your bottom dollar it is the sine function. The cosine function usually starts up at amplitude. Now, this could be a cosine function with a phase shift, but I'm not going to be that nasty to you. All right, what's the next obvious feature? Well, look at the max and the min. All right, so I can see that it has an amplitude of 3. All right, so I can put that in there. Now, we know that the sine function usually starts off as a bump and then goes into the dip. And this is a reflection of that. As a matter of fact, it's an x-axis reflection. So what do we need here? We need to put a negative sign, right? And that makes our sine function then flip. Okay, the next thing that we need to talk about is the period and phase shift, if any. And I don't think these guys have a phase shift. That would be pretty mean. Okay, so the period is the distance to complete a full cycle. Right, so I've got my dip, I've got my bump, and then I start here and I begin the dip again. So it does its thing in this distance right here, and then we can see that it's just going to repeat over and over again. All right, so our period here is going to be equal to pi. Now, I know the coefficient that belongs in front of the x. What I have to do is I have to go period, b goes in there, right? And we know that period is equal to 2 pi divided by b. Well, we can see from our graph that the period is pi. So what we're doing is we're back calculating then our coefficient to go in front of the x, and we can see that coefficient that front of the x is 2. There's our function. There's our answer. Working backwards. Graph to equation. Okay, what's the deal? The main features. Look for the origin. Does it go through the origin, yes or no? Look at the graph. Find the period. Okay, that's your two main things. Then look at your amplitude. And then you have to kind of think to yourself, is this a reflection across the x-axis, yes or no? All right, and from those three main features, you can almost identify just about any graph. All right, here's another problem. Okay, this is number 30, and there's a particular reason why I picked this one. All right, it asks you to make this graph right here. Well, I can see my amplitude is 1. All right, so there's no funky translations going on there. It's the cosine. And we have the t-table for this memorized. There's no vertical shifts and stuff like that. Looks like a pretty straightforward t-table. Okay, so we know that this is then going to be b, and this is going to do something to our period. Okay, so I go 2 pi divided by b, and when I end up doing that, then I get here that my period is equal to 4. In other words, the pi divides out. Okay, and it's usually at this point that, students lose it. Okay, you've got to remember that all of these guys, they're just numbers. Okay, this guy, it's 3.14, so we're going to say he's approximately 3. That means that this guy is approximately 1.5, so on and so forth. And it just so happens that our period, instead of being 2 pi, which is, 6.2, or we can just round it off to 6 for the purposes of graphing, it's just a number. It just so happens that this is a pretty number. And we need to fit it in up here. And it's not nearly as difficult as you might think. Okay, so what does that mean? That means my x values have to be divided by pi over 2. So when I do this, they all come out to be nice, neat integer values. Now, how am I going to plot this? Well, let's figure out what these guys are. I told you this was about 1.5. I told you this is about 3. So let's take this guy and let's cut him into thirds. And I did that because this is going to be about 1/2. This is going to be about 1, 1.5. Let's cut this into thirds. 2, 2.5, 3, 3.5, 4. And then we're done. And now then we can just plot these. 0, 1. 1 is about right here. And, oops, we better give our y-axis some values. What's this amplitude? 1 to -1. So that's simple enough. And then what's my next guy? 0, 1, 2. It's about right here. Plot that. 3. Plot that. 4. Back up to an amplitude of 1. And do not connect this with a B. Connect it with a dip and 2 half bumps. Okay, because this actually goes like this, and this actually goes like this. Okay, so what's the point of this problem? Just because you don't have pi in your argument of x, don't freak out. Remember, pi is just a number. I can express radians in any number I want. Remember, the domain of this guy is -infinity to +infinity. So I can plug in any real number. It does not have to have a pi in it. It's kind of nice if it does, because then that lets us know it's an angle. But an angle can be 4 radians. That is legit. All right, hopefully this has helped you, and you should be able to solve the rest of your homework problems on your own.